you remember doing three variable systems in Algebra 2?
Well, I didn't really get to finish Algebra 2. What? Because COVID?
Well, I don't know when you did this, but three variable systems are when you have an x, a y, and a z, kind of like three dimensions, right? These are lines in three dimensions. So these are called multivariable systems of equations. So we're going to start with an example of an easy problem where we're going to do something called back substitution. So the problem I'm going to give you has an x, a y, and a z, and we're supposed to solve for all three variables. So this is called row echelon form. Echelon means like a stair-step type pattern. Have you ever heard the word echelon before?
Yeah.
Like you guys are in the top echelon of math students here at the Untitled.
Yeah.
You're in the top tier, right? Like, or maybe not quite with calculus yet, but you know, second to top tier. So it's like a stair-step pattern. You kind of see that this kind of is up like that. So what back substitution does is it takes the answer for z and you back substitute it in to find the y, and then you take those answers and you back substitute them in to find the x. So this is a process you're going to use on every single problem. This one just starts out pretty simple because you already know z. So if you know z, you're going to plug it back in to the next up equation to find your y. So y plus 2 times 8 equals 6. And then you're just going to solve for y by subtracting 16. And then once we know y, we're going to take that answer and do what with it? Plug it into the top one. So now we know z and y. And we're going to take this top equation and we're going to take both of these and put them in here. So I'm going to do that over here. X minus a negative 10 plus 5 times 8 equals 37. So x plus 10 plus 40 is 50. And we get our final answer for x is negative 13. So we have three answers for x, y, and z, well, one answer for each. And we're going to put that as a coordinate. And what comes first in the coordinates? X. Go alphabetical, right? X, then y, then z. So you need to make sure you're putting all three of the values in the correct order or will not accept the answer. And what is that? So we have negative 13, negative 10, and then 8. Now that one is pretty simple and straightforward. If you have three variables, you should have three equations. That's called a square. Three equations, three variables. If you have a non-square system, you're not really able to find exact values for the variables. You would end up having an infinite type of solution. With A's, you remember that problem we did on the 7.2 homework that had A's? It was number 5. We can have A's, infinite solution. Okay. Any questions on this one before we do that? I have 2 more examples. This one here, it's because it was a minus y, and so that would have made it minus and negative from the original problem. Yes. Any other questions? All right, let's do the next example. The next example also has 3 equations. You might be missing an x or y in some of them. I picked one that was kind of like, I had 3 equations, but some of the things were missing. So let's search this. When I look at the space, because there's a y and then 2 z. I always put a line through my z's so they don't look like 2. Okay, so here's my system of equations. I just noticed that with the screen cancel I can do more than the recordings. I feel like it picks up smaller voice sounds even when I'm talking, and I don't know, I just noticed it in calculus. Like that. Okay, so I have 3 equations, and I have 3 variables. Some of the equations are missing an x, y, or z, and I need to pick one of the variables to eliminate. So in the last example, we had a z. That was just a number, right? So we can just plug it in. We don't have that here. So what we have to do is pick a variable to eliminate. You can eliminate x, or y, or z. You just have to pick one. Y. Okay. So you can see this top equation already has no y. So we can use these 2 equations to eliminate y. So what I'm going to do is I'm going to eliminate y by multiplying one of the equations by a number. In this case, just a negative because I have a 3 and a 3. So if I eliminate y, I'm going to leave this equation the same. I'm going to write it over here. It helps if you write your equations separately so that you lose some space. And I'm going to make this a negative 3y and a positive 4z equals negative 4. So I'm multiplying this equation here by a negative 2. Do you remember doing this in algebra 2? Alright, now I'm going to add these together, which does eliminate y. That would give me a 5x and a 4z equals 0. That's okay to have it equal to 0. That's nothing, you didn't do anything wrong if you get something equal to 0. Especially when there's variables. Okay, now I have this equation. I also have this top equation with no y, so I'm going to use both of those. I'm going to rewrite them over here. I'll use a different color. I like to color code things, but we do not have to. 2x plus 2z equals 2, and 5x plus 4z equals 0. So I'm going to eliminate x or z. Does it matter which one you pick? Nope. Which one do you want to eliminate? Which one looks easier to eliminate? I would say z. Yeah, because if you have a 4 already in the bottom, then you just have to multiply the top by negative 2. So we're going to multiply the top by negative 2. That's going to give us, I'll just put it down here, negative 4x minus 4z equals negative 2. So the z's cancel out, and I have 1x equals negative 4. I've now solved for x. Now, in the last problem, we solved for z first because it was given to us. But this problem, we actually solved for x. Now, what do? I have to back substitute again, just kind of going a different route, to find either y or z. Now, I cannot find y in these equations, right? Because these I canceled out the y. So could I use one of the other equations to find y? See how this one has an x and a y? I could use this equation to solve for y. And then I could also use this equation to solve, not this equation, I'd have to use this top equation to solve for z. Because that's x and z. The only number or letter I know is x right now. I have the option of plugging the x back in up here to solve for z, which is the same thing as this. So pick one that has a z in it, or a y in it. Plug it in, see if you can find the answer. So, which one to do first? Does it really matter? No. I think I'll solve for z first, since these had z in it. So I'm going to just use this equation right here, which is this one. So 2x plus 2 negative 4 equals 2. actually the same thing because I wrote 2x and 2.
Let me rearrange it, but I don't want you to see it backwards like that.
I'm just going to rearrange it real quick. 2 times negative 4 plus 2z. You still get the same answer because it happens to be the same 2x and 2z. Plus 8. Make sure you put your numbers in the right places, because if that wasn't the same value, I would have gotten it wrong. Okay, so now I have e. And now I just have to pick one of the y equations. Does it matter which equation I pick for y? Nope. I just have to pick an equation that has a y. So I can pick the second one or the third one. Plug in my 5 for z or my x, which is negative 4, and find my y. So you pick one of the 2 equations to plug into. I don't care which one you pick. I think I'll just use this one right here. In the middle. Okay? So 5x and negative 4 plus 3y equals 0. And then finish solving for your y. Now that I have all 3 variables, I have solved the system, and I'm going to write the answer in the correct order, which is x, then y, then z. So my answer would be negative 4, 8, and then 5. Okay? Questions? Alright, the third and final example I'm going to do for you is one of the ones that's infinite solutions. Just like number 5 on the 7.2 homework, I want to do another one of those with 3 variables so you can see that type of problem again. What happens when you have infinite solutions? Again, do you remember? Everything cancels out. Do you remember that from 7.2? What happens if some things cancel, some things don't? Like, what if you get, like, 0 equals 25?
No.
That's a no, right? No solution. So those are easier than the infinite solutions, because with the no solution, you just write no solution. But with an infinite solution, it'll usually tell you to let A be like Z or Y or X. Okay? So we're going to have an A in our answer. Any questions on this second example before we do the final one? Are you sure? Okay, final example. A few things to be aware of, just so you know. Make sure you write the problem down correctly. Okay? If you don't write the problem down correctly, that can be frustrating because you've like wasted 15 minutes doing a problem that you thought you were doing right, and then you got the wrong answer and wonder why it's wrong, and then you realize, oh, that was a positive 2 and not a negative 2 that I wrote down. Because it'll happen. Now, it happens more when you're picking problems from a book, but since you're doing the problem out of Web of Science, hopefully it won't happen because the problems are more separated. But in the book, it's easy. So, I'm going to make sure, as I write this problem down, that I write it down correctly. 3x minus 3y plus 6z equals 6. X plus 2y minus z equals 5. 5x minus 8y plus 13z equals 7. Okay, just double checking my problem to make sure I wrote it down correctly. Okay, I wrote it down correctly. Now what are we going to do? We're going to pick one of the variables to eliminate. X, so we consider any mistakes. So, for instance, rewrite these over here. We're not going to do anything to the top one because we don't have to. But we are going to multiply this by negative 3. So that would be a negative 3x and negative 6y, positive 3z, and then negative 15. Lots of nuns. I always double check when I multiply, go back and just check the numbers to make sure I multiplied them all correctly too, before I add. Alright, I have eliminated x from the first two equations. Now I'm going to use these two equations and multiply this by negative 5 this time. So, doesn't matter, I'm going to do it like right below this. So I'm going to say negative 5x minus 10y plus 5z equals negative 25. And then rewrite the bottom equation just the same way it is because I don't have to multiply it by anything. So, 5x. Add them together. Again, on purpose, we cancel out x. Now I figure out how many y's. 18 for each, so negative 18y, positive 18z, which equals negative 18. Now, if you take these two equations, and we want to eliminate x, but we've already eliminated x. We want to eliminate y or z, either one. What do we have to do? We have to multiply the top equation by negative 2, right? So we're going to multiply this by negative 2, so that would be 18y minus 18 plus 18. Okay. Put the other one in. And what happens? You get 0 equals 0. Is that true? Yes. So, what do we say our answer is? Well, usually it's infinite answers, but we can't just say like, oh, 1, 1, 1 works. Because if you plug 1, 1, 1 into those equations, it would not work. Okay, so what we're going to do is pick z to just be any number a. So we're going to use the same thing that we did before. We're going to say, okay, z equals a random a. Okay, if z equals a, then let's solve for y. So let's use one of these equations here, like this one in blue. We have, I'll just do it right here, negative 9y plus 9a. So notice I replaced the z with the a because I want to solve for y in terms of a. I'm so excited. Okay, so I'm going to subtract 9a and then divide everything by negative 9. So y equals 1 plus a. Okay, now finally, so I have z and now I have y. Now how do we find x? I replaced, see this equation here? I replaced the z with an a. That's all I did here. And then I solved for y. So I moved this over by subtracting it. And then divided by negative 9. So all the 9. So I just use whatever equation you want. But you can see that that middle equation might be the easiest to solve for x. Because the x is already by itself. I don't have to divide by 3 or 5. So I'm going to use the middle equation. But none of them are wrong. then I have minus z. Z in this case is a. It equals 5. Okay, so I'm using this equation right here. I'm going to put in my a's for x, or for y, and for z. Now all I need to do is solve for x. So I have to just distribute this and move everything over. So 2 plus 2a minus a equals 5. So I'm going to subtract 2 from 5, which is 3. And what's a minus a? 2a minus a. 2a minus a is a, right? I'm going to minus a. So it has infinite solutions. Z we named a. That meant y was 1 plus a. And then x is 3 minus a. So my answer can't be 1, 1, 1, but could I pick a to be 1? Yeah. And if a is 1, then what is this y? 1 plus 1 would be 2. And what is 3 minus 1? 2. So 2, 2, 1 would work. You could try it. Would 2, 2, 1 work in any of these three equations? 2 plus 4 is 6 minus 1. Yep, it's 5. So if you pick any number you wanted for a, it will give you the other values that you could plug in. Okay, that's an infinite solution. That one's harder than no solution. And maybe even harder in your opinion than just getting numbers, right? Like a pretty sort of